building tools that support scholars, storytellers, and designers alike. Last year, he collaborated with game developer Kevin Markley to design an AI NPC environment for research communication in Unreal 5 that you're going to be able to test later today. So thank you very much, Dylan, and looking forward to your presentation.
Thank you so much. For anyone who's following along with their own laptop or following along at home, I'd like you to refer you to these slides so you can view the content in full resolution wherever you are. Today, I'd like to start with a comic from XKCD about machine learning. I think it speaks well to today's themes about noise and play. The purpose of today's presentation is to offer a rigorous, critical, and current state view of Gen AI and gaming with transformers and diffusion models. And my central argument today is that stochastic or noisy processes are not flaws, but essential creative engines driving innovation. And as a secondary claim, I assert that these techniques enable us to direct game projects with newfound facility and joy. I've structured this talk into 3 levels, covering the main ideas I'd like to communicate today. Each section pairs technology with concrete examples and broader implications for game creators and critics alike. Let me begin with a fundamental concept that will help us understand everything that follows. That concept is stochastic gradient descent, or SGD. Now, stochastic gradient descent is the workhorse of modern AI. It proves that randomness builds structure. Stochastic gradient descent, or SGD, is an optimization algorithm that powerfully demonstrates how randomness creates structure. And unlike traditional methods that process all data at once, SGD randomly samples small batches, calculates adjustments based on those samples, and iterates rapidly. Now, in many discussions about how this process works, the metaphor of the mountain is applied. And here's how many folks want to have you begin your adventure. They say, imagine you're hiking down a mountain in heavy fog with limited visibility, and you're watching your steps carefully. The first thing you do before you take a step is you kind of measure the steepness of where you're standing. Then you take a step in the direction that goes downhill fastest because you're trying to get off this mountain. And then after you take that step, you measure again from your new position, and then you just repeat this process until eventually you're at the bottom of the mountain. By trusting this partial an iterative process, a little bit recursive in nature, you often are going to reach the valley faster than hikers who are waiting around for the fog to clear, waiting for perfect clarity. And that willingness to act on incomplete information is part of our theme today, how we extract signal from noise. Now, the magic of SGD is that by embracing randomness, by using incomplete information, we often find better solutions than methods that try to be perfectly precise. And this parallels our central theme of finding that structure. Now, the only problem with this graphing calculator version of the explanation is it doesn't feel as though we've learned very much about how SGD works in the context of its real practice, which is very often in the service of neural nets. So to help you all today, I created a game just for this conference, and you can visit it if you're on a computer, not a mobile device, at this website, which we'll go to now, and I will demo this game that was made just for our group here today. 1 second. Okay, so the game is called Grandma's Television, and if you are old enough, you remember a television that looked like this. You might know it from the rabbit ears effect, where you would kind of adjust the rabbit ears to get rid of all of the staticky signal. And if you're playing at home along and you don't think it's staticky enough, you can just click that randomize static button, and I've got like a CSS like creating static over the image. Now, you see here we have these knobs on Grandma's TV. The knobs all go to 11, obviously, but we want to adjust these knobs to try to get the image clearer. So here I've made the owl a little bit clearer, and here I'm going to fiddle with this parameter too. I don't know which one's the clearest. What do you guys think? I want to see the face. Okay, so I'm going to come around here. Oh, it's getting very clear, and you can see here that the static rating of the image is going down. And my goal as the player is try to get it to 0. And ooh, I'm like bumping it up. Let me try to get it really low. Okay, we're getting really low, and we won. Okay, I've perfectly tuned it. Now, if I randomize the static again and I apply this optimization algo, you'll see that it'll self-adjust and find that for me without any kind of human interference. Sometimes it'll get trapped in a local minimum and have to rejigger some of the dials so that it can refine the lowest one. But it basically does what humans can do on grandma's TV with 4 dials. These 4 dials are 4 parameters, but like a large language model has many billions of dials, many billions of parameters, so to speak. So I hope this little game is something that you cherish as a little takeaway from the day. You can have it for free. Compliments of me. Okay. So let's move on from grandma's television and talk about some sources of creative noise. I've identified some sources here just to help us understand a little bit better, and I'll be talking about them in detail. So use this as a support for what I'm about to say. Now, the concept of noise in AI game development isn't just about static or unwanted interference. There are several different types of noise that serve as creative engines for modern systems. We have the Gaussian noise that's named after the bell curve distribution discovered by Carl Friedrich Gauss. It forms the foundation of diffusion models, as some of my colleagues have already alluded to today. And when diffusion-based image generation tools create assets or meshes from scratch, they begin with some pixels of Gaussian noise and systematically refine them to create a coherent image. Perlin noise is made famous by Ken Perlin. Did anyone see the original Tron movie? Yeah. So Ken Perlin designed the clouds for that movie, and that cloud technology he made for the movie, it bears his namesake. He won a technical award from the Academy for that, and it's pretty awesome that, you know, even though he made the clouds for Tron, 40 years later, we're still using his approach to build entire worlds. Now, unlike pure chaos, Perlin noise has some internal coherence to it. So instead of creating static in the sky, it creates something that looks like a puffy cloud. And games like Minecraft are using versions of that. Now, this third one that I have labeled RNG here, or random number generator, this is also known as mathematical stochasticity. This is very popular for games because it creates that illusion of chance. And even if it's not perfectly random, we as the player like to feel lucky, right? So that creates a certain level of drama. But we might also get noise from training data variance and prompt variability as another type of noise, right? That's inherently fuzzy. We'll talk a little bit about these kind of fuzzy sorts of prompts in a little bit. But I'd just like to point out that these sources of noise aren't adversaries to be eliminated. They're raw materials to be shaped. The art of denoising isn't about removing the randomness, but transforming it into something structured that retains a spark of unpredictability, that makes games engaging, makes environments feel natural. Okay, let's play a game. You guys know Jeopardy. Here's how it works. Someone's going to call out what dollar value they want, and then I'm going to read out the clue. Your goal is to guess the tool, or guess the system, or guess the approach. Okay? So I'll tell you the input data, and I'll tell you what SGD is doing, and then you guess the system, okay? Let's start out for $100. The clue is, for $100, this system receives text as its input, and SGD learns to predict the next token from massive text corpora.
What is ChatGPT?
Correct, $100 to Andrew. Okay, for $200, Alex, this system receives image-text pairs, and SGD learns to reverse Gaussian noise from images. That's right.
What is diffusion?
What is diffusion? What is stable diffusion? What is Dolly? What is Midjourney? And we are up 300. I'd like that next one, $300, Alex. This system receives audio as its data input, and SGD learns mapping from audio features to tokens. Very close. Think the reverse direction. Reverse direction. Because audio is the input. What is whisper? Very good. For $400, this system receives low resolution frames and motion vectors, and SGD learns how to reconstruct high resolution frames. Very good, $400 over here for a DLSS. And for $500, this system receives images and camera poses. SGD learns the size and opacity of lights and colors for 3D scenes. Any ideas? I'll give you that last part of the clue again. It's used to reconstruct a 3D scene. You're close. Okay, no one gets $500, but no one lost $500, very importantly. The answer here is Gaussian splatting, or radiance fields. Very good. Okay, now we're on level 2. This is the asset warp pipe. Now, in classic game development, randomness was treated like a defect to be ironed out. Today, it's our raw material for creativity. Our models are beginning as a blizzard of Gaussian static. And we coax it step by step into a textured prop or a fully lit scene. And we might be using transformer-based generators to generate meshes for them, geometry for these objects, predicting these vertices as naturally as one might predict the next word with a language model. And leaning into stochasticity changes the economics of artistry for game making, quite frankly. One trained model can mint thousands of level variants at almost no additional cost. It gives designers a fountain of replayability that handcrafted maps can never match, at least in terms of scale. And more importantly, it keeps surprising us. Every fresh random seed is an invitation to discover forms that humans may never have the time to think of or may never want to consider in the first place. Now, the task behind us as modern game designers is not to silence that static, but to shape it, turn that raw noise into experience that players want to explore again and again. Enter Edify 3D. Edify 3D is a vivid example of putting this noise to work. I'm going to show you something, but first I want to kind of explain what that is. In this example, you're going to see a designer give Omniverse a text prompt. And that text prompt is going to then see the cloud of Gaussian static across a latent 3D canvas. And as the diffusion steps gradually tease shape from that chaos, a transformer will predict how each polygon should mesh with its neighbors. And within seconds, that fog will clear, and we'll have everything we want from our design environment. We'll want geometry, we'll want collision holes, we'll want lighting rigs. And crucially, we as the designer are not going to leave the loop. We're in control of this loop. We're going to nudge it in the directions we want, making adjustments as we fine-tune it. And this will take a minute or so to watch. Enjoy. And that's how quickly we can go from just the simple ideation to something we can work with, test with, kick the tires on. And I want us to think about, how we spend our hours in game development, right? Are we going to be spending all of our time tinkering with things that players may never see or players don't like, right? Are we going to be daring and bold and experiment and iterate faster than ever before so that we can keep players coming back for the next patch, the next season, the next premiere? I'm not going to talk about this in detail just because we're pressed for time, but there's also a project called Oasis, another one called Diamond, that use diffusion techniques to basically create the world as you go. So if you were to go to this website on your own time, you could steer a game where each frame in the game gets generated as you move forward to it, but there is no game engine itself. It's an engineless game, so to speak. Okay, moving on to level 3, narrative instances. I want to talk a little bit about something that I think affects us all, is how we harness this procedural power, right? How we make compelling stories, how we share them with our players. Now, we're very lucky to have narratologists in the room with us today who focus on ludology and game development, game studies. And I want us to be reminded, thanks to Hartmut's excellent lecture too, that we have this lens of thinking about games already in terms of a proto-story that lends itself very well to thinking about games in the AI era. Okay? The proto-story is an unfixed content for our interactive digital narrative. It's a charged volume of possibilities rather than a single story that comes out, like almost like a movie tells one story, a game could tell a million stories, right? And I like to think about Hartmut's approach, and please correct me if I'm wrong over drinks later, I like to think about it as the magnetic field around a compass, right? You can't see these lines as the person who's interacting with the compass, but the needle can detect which way the magnetic fields are going. And I think about LLMs as the perfect companions for that field. Instead of branching down hard-coded dialogue trees, LLMs can sample from the proto-story's latent space, improvise dialogue, improvise quests, provide twists that are coherent because they remain tugged by those underlying vectors, right? These could be constraints about the lore of the game, the psychology of the NPCs, or thematic beats. And if we think about the proto-story as a prompt, imagine this for a second. Here I have an image, and I want you to visualize that you're approaching this desert outpost. It's like Star Wars without the sci-fi, okay? And in this town, it's kind of like Waterworld. Everyone's desperate for this rare resource, and you're going on quests to dig a new town well. And the thing is that none of the story has been written yet. We just have this core idea. And instead of designers trying to plot every single branch and tailor every possible experience the player will have, I want us to think more in the emergent direction of how will these tales tell themselves, right? How will the stochastic storyteller provide the moment-to-moment weaving while we provide the larger scale direction? That is to say, instead of scripting the script, how do we script the space? How do we get from narrative encoding to narrative jazz, right? We want to have riffs, we want to have beats, right? But we want it to feel fresh every time as well. So this brings us to kind of an experimental project called Covert Protocol. Now, Covert Protocol is a demo from NVIDIA and InWorld where they work together using a bunch of local computation with some cloud computation to create an experience where you could interact with an NPC who only had that proto-story to build off of with some kind of story beats to skeleton around to. And as you watch, I want you to understand some of the things that are happening. First of all, the reason the responses are so quick is because they're using like on-device, whisper and text-to-speech systems. Second, we maintain coherence with the game world and the story by operating within the guardrails of what's supposed to happen to move the story forward. We're not just saying, hey, tell us about an old Western. Like there has to be a mission, and we're going towards that mission with every step. And then the third thing is that we're getting some type of face lip sync synthesis happening, which is also important, right? Because we want it to feel real, and we achieve that verisimilitude by making sure that it doesn't just come out Oblivion style with awkward movements. Okay, let's watch the video. It'll speak for itself.
Do you know what room Martin is staying in?
Oh yes, because I am definitely Martin's assistant and know all of his whereabouts. No idea.
Diego is one of the main characters in Covert Protocol, a demo that brings together the best of NVIDIA and InWorld to unlock social simulation game mechanics. In this video, we'll be diving into how InWorld is powering cognition, perception, and behavior for the AI agents in the game. Diego is an executive at Nexalife. He has a rich backstory powered by his personal knowledge, as well as common knowledge that he shares with other characters. When you meet Diego for the first time, he is brusque and dismissive. What's your speech about?
Not interested in discussing it with someone who isn't a VIP at the conference. Moving on.
The player's response can be captured on device and passed to NVIDIA Riva automatic speech recognition and then passed to in-world for inference. Now let's see what happens after the player has obtained the conference badge and pretends to be an attendee. You look sharp. Where'd you get that suit?
Thank you, sir. I have a personal tailor who always makes sure I'm dressed to impress.
Behind the scenes, several in-world systems and models are working together to orchestrate Diego's response. The player's voice input can be captured on device by NVIDIA Riva automatic speech recognition, and the text transcript is then passed to in-world for inference. When the player introduces themselves as Alex Miller, the name on the conference attendee badge, this triggers a mutation of Diego's motivations and demeanor, making him more collegial and friendly with the player. Intent-based mutations are also used to trigger changes to the player profile from tourist to attendee. To aid an agent's cognition, we've added a customized reasoning step to evaluate the interactions and dynamically evaluate motivations. Customized reasoning allows AI agents to simulate human-like decision-making processes, engaging in complex interactions, pursue their own goals, and create dynamic gameplay scenarios. Strict safety filters are enabled for topics like politics and religion, which are not topics that the characters should comment on. Every interaction draws on Diego's basic character sheet, which informs his perception of the game world and lore, as well as his core ego and persona. In-world's cognition and perception systems also output character behavior across multiple data streams to orchestrate the full character performance. NVIDIA Audio-to-Face and NVIDIA Riva automatic speech recognition can be run on device to augment our character's facial animation pipeline. We pass emotion parameters so developers can sync these to client-side animations. As Diego warms up to the player, he will lean forward to indicate interest. I have some insider information about one of your competitors. I'd love to meet up later and discuss.
Sounds intriguing. But unfortunately, my schedule is quite packed with conference events. Maybe we can discuss over dinner? My treat, of course.
Voices are synthesized at runtime in the cloud for expressive vocal performances. Covert Protocol is just a first step and one example of how developers can take advantage of hybrid deployments to integrate advanced AI capabilities into their games. We're continuing to make progress on bringing even more powerful language and multimodal models on device.
I'll continue because we're pressed for time. One of the big theories behind this was already presented to us by Nicholas Seelis, right? That is the theory of the three-actor AI, that the story actually is going to be constituted in concert with the player, and that's what this example, exemplifies so well, is that there is a way to create the story in concert with interaction with the player, and that type of co-constituent narrative is essential. This is, of course, in contrast to something like The Witcher 3, where we created 36 different endings based on decisions that were made along the way. Now, I want to just quickly jump to something a little bit more inspirational, right, and summarize as we wrap up. First, there's noise. It's everywhere. It's valuable. We need to use it. We have many talks happening this weekend about how to transform it more effectively. Second, there is a reality regarding our craft, right? Over the past 4 decades, gaming changes at the frontier with technology. We'll have to decide how to use these tools judiciously and effectively for our audience. The third thing is, if Gary Gygax was listening to all of this today, it would be standing the model of D&D and original RPG construction on its head. The idea that it's not just one person who tells the whole story. It's in fact going to be in the future us telling the story to the game so that the players can share that story going forward, and that is something really novel for us. Now, I would like to end with something inspirational. It was something that inspired me. I hope it inspires you as you build your games.
Quentin, it's not your job to create your vision. It's your job to have a vision. And then it's your job to hire talented individuals, to hire talented artists who understand your vision. And you articulate it to them. And then they take your vision and they create it. And by them creating it, you part it back a little bit, you add a little bit to it, but your vision is still a two-dimensional vision. They will take the different elements of your vision and make it three-dimensional. And then you'll get back more than you gave them, and then you'll know even more what you're talking about and what you're seeing, and then the vision will get filled in. You think you have to do everything, and you don't. You don't need to know anything about sewing to have wonderful costumes in your films. You just need to express what you want to the costume designers. You don't need to have a degree in engineering to have magnificent sets in your pieces. You need to describe what it is you want. You don't need to know how to take a bunch of different light stands and put them together to create a specific lighting effect. That's not your job. You don't need to know any of that. What you need to know is you need to have a vision and you need to know how to express it. And then you let the other people take it and do it for you. That is what a director does. I can't tell you how that sword of Damocles that it hung over my head from the moment that I started to try to really seriously consider being a filmmaker, how daunting it was. And because I didn't go to film school or anything, it was like there was always this argument that I always have in myself. Is this real or am I just being a dreamer? And the fact that I didn't know how to do those different things always put me in the debate amongst myself, dreamer or artist. That was always ammunition for the dreamer side of the debate. And in one answer like that, that sort of Damocles went away. Because I did have a vision, I did know what I want, and I could describe it. That I could do, I can describe it, I can talk about it. That is what I know I can do. And pretty much since then, that's what I did. And that is how, if you think my films have a certain look or a certain aesthetic, that is how I've created it. I've worked with very talented people and described to them ad nauseum, you know, through both my descriptions and through cinematic examples and through comic books and through all kinds of different other little multimedia things that I like to evoke. That's how I've gotten it across.
Thank you.